Hello kids, in our last class we have done the first figure out of 5.1 and in today's class let's do the second figure it out for 5.1 only. So let's start with the first question. So by now we are very much clear with the concept of multiples, factors, common multiples and common factors, right? So let's start with this exercise. Question number 1 is find all multiples of 40 that lies between 310 and 410. So let's pick this question. Answer number 1. So what I'm going to do here is I'm going to start with the table of 4 till it reaches to the very next number of 310. Okay, so we have 4 multiplied by 7 is 280 and 4 multiplied by 8 is 320. 40 multiplied by 8, it will give you 320, right? So this 320 is the first number which is greater than 310. Now what we have to do next? We can take the next multiple of 40, that is 40 multiplied by 9, it will give us 360. Then we will get 400 and after 400 we will get 440, but we don't want 440. Why? Because we want the numbers between this range 310 and 410. Okay, so what we have got here, we have got three multiples and they are 320, 360 and 400. Okay, so I'm sure that you have understood that how we have taken them out, but still I'm telling you again that what we have to do, we have to take the table of 40 till the number which is greater than 310. So in the table of 40, the first number which is greater than 310 is 320, which comes at when we multiply 40 with 8. Okay, so this is 40 multiplied by 8 will give us 320. The next number is 360 and the next multiple is 400. After 400, if I multiply it by 11, I will get 440, which is a multiple of 40, but it does not follow in the given range. Okay, so that's why what we are doing, we are picking these three multiples. So these three are the multiples which are coming in this range. Okay, now let us go to second question. Who am I? I am a number less than 40. One of my factors is 7 and sum of my digit is 8. So what it is saying is that I am a number and I am less than 40. Okay. And one of my factor is 7 and the sum of my digit is 8. So who I am. So how we are going to do this question, kids, here is we will write here. Okay, I am a number less than 40. So this number, I am taking this number as n. Let the number be n. Okay, so n, I am a number and I am less than 40. One of my factors is 7. So that means this n has two parts. One part we don't know. The second part is 7. Okay, one factor we don't know. The second factor is 7. That means if we multiply 7 with this factor, we will get this number, right? That is the meaning of factor. So, and the sum of my digit is n. What it says is that the sum of my digit is 8. That means if we add the digit of which are there in n, it will give me 8. The sum of digits is 8. And now what we have to do is we have to see that what is the number. We have to find out that who I am, what is my value. So kids, let's do this thing. Okay, if I multiply here, if I multiply, I will start with 2. Okay, if I multiply 7 with 2, I will get 14. I will get 14. I am just taking this for rough work. If I multiply 7 with 2, I will get 14. But the sum of my number should also be 8. And if I add 1 plus 4, I will get 5. Okay, so this is not true. Now I am taking the next number 3. 3 multiplied by 7 is 21. If I take 3 here, it is 3 multiplied by 7, 21. And the sum of 2 plus 1 is again 3, which is also not true, right? Now, what can I do next here is I can take another number. So I'm taking another number as 4. If I take 4 here, 7 multiplied by 4 is 28, which is less than 40 again, but the sum of the digit is 10. Okay, which is also not true. Now I will take 5. 5 multiplied by 7 will give me 35. And if I add these two numbers, 3 plus 5, it will give me 8. So that means this is the number we were looking for, 35. That means the value of n is 35 here. And the two factors are, one is 7, the other factor is 5 here. Okay, so I hope you understood this. How we have done, we have to find a number which is less than 40. One of the factor is 7 given to us, and then the sum of the digits, the number of digits here, the sum of those digits should be 8. Okay, so what we have done, since one factor is given to us, we are starting with the all the numbers, possible numbers. So we have taken 2 first. So it will give us 2 multiplied by 7, it will give us 14. 4 plus 1, 5. The sum of digits should be 8, but here we are getting 5. So we have to ignore 2. Next, we are multiplying by 3 and we have got 21. 3 multiplied by 7 is giving me 21. Okay. And now 2 plus 1, 21. If I am adding the digit of the number 21, which is 3. So again, it is not true because we need 8. With 4, it is giving us 28. The sum is not 8. And then with 5, it is giving us 35. And when we add the two numbers of 35, it is giving us 8. Okay, so that means the number which we were looking for is 35. This is the number. The one factor is 7, which is already given to us, and the second factor we have found out is 5. Okay, now this was the A part of the question. Now coming to the B part, it says I am a number less than 100. Two of my factors are 3 and 5. So now what it is saying is that I am a number, let's say the number is n, and I am less than 100. Two of my factors are 3 and 5. Okay, and one of my digit is more than the other. So the number, like in the earlier case, it was saying the sum of digits should be 8. Here the condition is one of the digit is one more than the other, is one more than other. And then what is the number we have to find? Okay, same technique we can use. Let's do this question. So we have 5 multiplied by 3. 5 multiplied by 3 will give us 15. Okay, so let's try with 15. 15 is given to us. Now what we will do? We will start with, why we can also start with 1 kids, because it was giving us a single number here, so that's why I ignored. Still 1 multiplied by 5. So if I'll take 1 multiplied by 5, it is giving us 15. Okay, 15 is less than 100, but one of the digit is one more than another. This condition is not true. So I'm going to 2. 2 multiplied by 5. It is giving me 30 here. Again, the condition is false, this condition. Next, we have 3, which is already here. So it will not be repeat. Okay, we can repeat also. Yes. So we have 3. I multiply by 15 because we have already multiplied. So this is 15 multiplied by 3. It is giving me 45. One of the digit is one more than the other. So see kids, this condition is true here because one of the digit is one greater than the another. In the number 45, when we multiply here, we are getting the number 45, where one digit is one more than the other. 5 is one more than the 5, correct? So this is the number we were looking at. So what will I write here? Wait, I'm writing here. The number we were looking for is 45. This number is less than 100 and the another factor was 3. Okay. So same way we can do any question here. Now let's go to the third question. So the third question here is a number for which the sum of all its factors is equal to twice the number is called as perfect number. So if we have any number whose and which has some factors also, and the sum of factor is twice, it is double the number, then that number is called perfect number. Example, 28 is a perfect number. 28 is a perfect number. Why? Because its factors are 1, 2, 4, 7, 14 and 28. And when we add all these, that is when we do 1 plus 2 plus 4 plus 7 plus 14 plus 28, we will get the number 46. And this 56, sorry. And this sum is exactly the twice of the given number. So that is the condition for perfect number, that the sum of the factors should be exact twice of the number itself. Now what we have to do is find a perfect number between 1 and 10. Now we have to find a perfect number between 1 and 10. So kids, let's start this. I will start with 1. Okay. So for 1, what are the factors? 1 only, which is not the twice of the sum of the number because it is 1 only. So now let's go with 2. So for 2, the factors are 1 and 2. And if I add these two factors, it will give me 3. This 3 is not, this is not equal to twice of this number. Yeah, it is not equal to twice of 2. So this is false. 2 is not the perfect number. Now I will take 3. So for 3 we have 1 and 3 are the factors. If I add this 1 and 3, I will get 4. And again 4 is not twice of 3. It is not twice of 3. So 3 is also not a perfect number. Going to 4, we have 1, 2 and 4. These are the factors. Now when we add, we will get 7. And 7 is not twice of 4. Okay, it is not the twice of the given number. So here 1, 2, 3, 4. None of these are the perfect number. Coming to 5. For 5, we have 1 and 5 are the factors. Adding the factors, we will get 6, which is again not twice of 5. Okay, this is not 5 of twice. That means it is also not a perfect number. Now we will take 6. So in the case of 6, we have 1, 2, 3 and 6. These all are the numbers. Now let's add. 6 plus 3, 9. 9 plus 2, 11 plus 1, 12. So we get 12 as the sum, which is equal to twice of 6, because twice of 6 is nothing but 12, and here also the sum which we have got here is 12. So that means 6 is our perfect number. Now let's take 7. For 7, we will get 1 and 7. The sum is 8, which is again not equal to twice of 7. So this is also not a perfect number. Going to 8, we have 1, 2, 4 and 8. Okay, let's add them. 8 plus 4 is 12. 12 plus 2, 14 and 1, 15. Again, 15 is not twice of 8. Okay, so that means it is also not a perfect number. Then we have 9. 1, 3 and 9. When we add, we will get 13 here. And again 13 is not twice of the given number 9. So it's also not a perfect square. The last one we have 10. So for 10 we have the factors as 1, 2, 5 and 10. So let's add. It will give us 10 plus 5, 15, 17 and 18. 18 is also not the twice of the given number 10. So that means from 1 to 10 we have only the number 6 here, which is a perfect number. Okay, easy. So I hope you have understood what we have done. First of all, we have find out the factors and we have added the factors. So the condition for a perfect number is the sum of the factor should be equal to should be equal to twice of the given number, which is not true in any of the case except 6, because in the case of 6 we have got the sum as 12, which is equal to twice of the given number 6. Okay, so this is done, and now let's go to question number 4. Question number 4, kids, I am doing here. Find the common factors of all these numbers. So kids, we have already done such questions in our grade 5. I'm going to pick 2 questions here. Okay, I'm starting with the first part, 20 and 28 first. What we have to do, we have to find their factors. So for 20 the factors are 1, then 2, 3 is not a factor, 4 is a factor, 5 is a factor, 6 is not, 7 is also not, 8, 9, 10 is a factor, 11 is not a factor, 12 is not a factor, and then straight the next factor is 20, the number itself. Okay, so these are the factors of 20. 1, 2, 4, 5, and then we have 10 and 20. Now the next number is 28. So first is 1 is a factor, 2 is a factor, 3 is not a factor, 4 is a factor, 5 is not a factor, 6 is also not a factor, 7 is a factor, 8 is not a factor, and then we have 9 is also not a factor, 10 is also not a factor of this, 11 is also not, 12 is also not. Then straight away we can go to the number 14. 14 is a factor. Okay, and after 14 what we have is 28. Okay, this is also a factor. So what are the common factors? The numbers which are common in both. Okay, so they are, I'm writing here, common factors. Common factors are 1 is common in both, 2 is common in both, 4 is common in both. Okay, so these are the common factors of 20 and 28. 1, 2 and 4. Okay, next I am taking is D part. B and C, kids, you have to do yourself because we have done many questions like this in grade 5 also. 5, 15 and 25. So for 5 the factors are 1 and 5, right? For 15 it is 1, 3, 5 and the number itself 15, and for 25 it is 1, 5 and what is the other number? 1, 5 and 25. So what are the common factors? Common factors can also be written as CF. Okay, so common factors are 1 and 5. These are the two common factors here. Okay, so next is question number 5 here. Find the 3 numbers that are multiples of 25 but are not the multiples of 15. So kids, let's do this question. Question number 5. What I'll do is I will first write the multiples of 25. Let's write down first 5 multiples of 25. Okay, so this is multiples of 25 and they are 25, 50, 75, 100, 125 150, 175, 200 and so on. Okay. And now coming to 50. For 50 it is 50, then 100, 150, 200, 250, 300 and so on. Now what is asked here is we have to find any three numbers that are multiples of 25 but not multiples of 50. So if I compare here, first number is 25 itself. It's a multiple of 25 but it is not a multiple of 50. 50 is coming in both, so we have to ignore it. Then we have 75. 75 is a multiple of 25 but not of 50. Okay. Next is 150, which is multiple of both. And here it is 125. So this 125 is a multiple of 25, but it is not a multiple of 50. Okay. So this is very easy. What we have done is we have written the few multiples of 25 and few multiples of 50. And what we have to do is we have to find any three numbers that are multiple of 25 but not of 50. So the first number is 25 itself. It is not coming in the table of 50. And then the 50 is here in both. The very next number is 75, which is a multiple of 25 but not coming in 50. And then 100 is present in both. The very next one is 125, and if I ask you the next one after 125, it will be 175. So let's write down this also, and this way you can find out the common multiples, the multiples which are common and which are not. Okay. So next we have question number 6 here. So what we have here is Anshu and his friends play the Idli Vada game with two numbers. Now, we have done the Idli Vada game in our last class. So, Anshu and his friends, they are playing this game with, they are playing it with two numbers which are both smaller than 10. So, what they are saying is they are playing with the two numbers which are, both the numbers are less than 10 here. The first time anybody says idli vada is after the number 50. So that means first time they will say idli vada. And we know that idli vada would be said when it will be a factor of both the number which on which we will say idli and on which we will say vada. So idli vada would be said after 50. Okay. So what could be the numbers which are assigned to idli and vada? This we have to find. So kids, see here. We first of condition given to us is both the numbers should be less than 10. Second thing is given to us here is that on this number idli would be said, on this number vada would be said, and idli vada would be said first time, let me write first time after 50. Okay, after 50 it would be said. So that means this is the rough work kids I'm doing here, and you should also think it this way. Okay, so what we will do is if I start with the table of 2, the maximum number, if I multiply, if I take one of the number as 2, considering it's a multiple of 2 here, the maximum number I would reach here is 20. Okay, and this 20 is less than 50. Okay, so that means 2 cannot be one of the number. Okay, similarly if I take 3, if I take 3 here and I take 3 multiplied by 10, or let's say I take 3 multiplied by 9 here, then it will give me 27. 3 multiplied by 10 will give me 30. Again, it is very less. So in the same way I can go till 5. 5 multiplied by 9 will give me 45, and 5 multiplied by 10 will give me 50. So that means till 5 we cannot take any numbers. Why? Because here first time when it is said, it is after 50. Okay, so the product which we should get here should be greater than 50 kids. Okay, so let's try with 6 now. After 5 we have 6. So 6 multiplied by what number will give us something which will give us a number greater than 50. Let's see. We have 6 multiplied by 8 as 48 and 6 multiplied by 9 as 54. So that means if I take one number as 6 and the other number as 9, then the product is 54, which is first, which is greater than 50, the condition given to us. So if I take this number as 6 here and this number as 9 here, both the numbers are less than 10, and the product of both the numbers, we know that when the product of both the numbers will is 54, which is greater than 50. Okay, and at this product, at this multiple, only idli vada would be said. So the numbers are 6 and 9. These are the two numbers. Okay, so I hope you understand this, but again I will repeat this for you. We have to find two numbers which are less than 10, and idli vada, that is for their product one, the very first time when idli vada would be said, that is their product, it should be greater than 50. Okay, then what we have done, we have started with 2 and we have seen that if we take one number as 2 and other as 10, in fact it should be less than 10. Then if we take it as 9, then it is giving us 18, or the maximum number is also 20. Okay, and this 20 is very very less than 50, but what we need is, we need something which is greater than 54. So the next number we took are 3 and 9, product is 27, which is again less. This goes up to 5. So with 5 also, the maximum number we can reach here is 45. We cannot take 10 kids, just ignore this. Why? Because the number should be less than 10. So the maximum number is 5 into 9 we have taken here, which is giving us 45, which is again less than 50. So we will ignore this. So what we'll do, we will go to 6 now. With 6, we will multiply 6 with a number till we get a number which is greater than 50. So 6 multiplied by 9 is 54, which is greater than 50. So that means the first number here we can take here as 6. On 6 idli would be said, on 9 vada would be said. Both the numbers are less than 10 and their product, that is 54, that is the first time on which idli vada would be said. Okay, so again I'm writing here, for idli it is 6 and at 9 vada would be said. And again these will be repeated on their multiples, like for idli would be repeated on 6, 12, 18 and so on, and vada would be repeated on 9, 18, 27 and so on. Okay, so this is done. Now let's take the question number 7 here. In the treasure hunting game, Grumpy has kept treasures on 28 and 70. What jump size will land on both the numbers? So kids, this is easy. What we'll have to do is, we will take here 28 and 70, and what we are going to do to find out that the what is their jump size here is, they are common factors. Okay, so let us do this quickly. The common factors of 28 are, we have already done, it is 1, this is 2, then we have 4, we have 7, and after 7 we have 14, and then we have 28. And for 70, what we have is, we have 1, and then we have 2, and then we have, no, we don't have 3, 4 also we don't have, not 5 we have here, 6 we don't have, 7 is here, and 8 is not there, 9 is not there, 10 is there. Okay, and after 10 we have 11 is not there, 12 is not there, 13 is not there, and 14, with 14 we have this. Next, after 14 what we have is, after 14 we have with 28, we don't have with this with 28 also, and next we'll have this with the bigger numbers is 35, and then we have 70. So now what are the step size? Step size should be something which is common to both. So jump size, sorry, not step size, this is jump size. It can be what? Common factors. It can be 1, again common, it can be 2, it can be 7, 7 is common, 4 is not common, 5 is not common, and then we have 14. 14 can be a jump size. So these are the common factors. These are the common factors to both of these. So they can be the jump size. Okay. Now next question 8 I am leaving to you kids. This is very easy. So I'm giving a hint here. In the diagram below, Guna has erased all the numbers except the common multiples. These are the common multiples. Find out those numbers. Those numbers could be, and fill in the numbers in the empty regions. So if I start with C, these are common multiples to many. These can be common multiples to many kids. You can take 2 and 4 here also, because they will come in the table of 2 and they will also come in the table of 4. Okay, so we have many options here. They can be 2 and 4 here. Similarly, if you take another set, it can be 4 here, it can be 8 here, right? And next it can be 8 here, it can be 12 here. So there are many answers to it. It can be 2 4 one set, it can be 4 8 second set, it can be 8 12. So you can try with all these numbers and you will get the products, because these are even numbers and they come in all these numbers 2 4 and 8, and there are more to it also. But I just I want to give you this as a homework where you can try with these all pairs. With 2 you can write the multiples of 2 here and 4 here, and second time 4 here and 8 here, and then 8 here and 12 here. Okay, this will work for all of these 3 pairs, right? Next is find the smallest number that is multiple of all the numbers. Wait, what we have to do here is, I'm writing, right, find the smallest number that is multiple of all the numbers from 1 to 10 except. So kids, what we have to do here is we have to find the smallest number that's multiple of all the numbers from 1 to 10, which is nothing but LCM, the least common multiple starting from 1 to 10, except 7. We don't have to consider the number 7. So let's do this. We have done many such questions in the previous grades. So we are writing down all the numbers here. 1 2 3 4 5 6. We have to ignore 7, 8, 9 and 10. Now for 1 is the multiple. For 2 it is 2 straight away. 3 is 3. 4 it is 2 into 2. For 5 it is 5. For 6 are these two are the 2 into 3, and then for 8 2 multiplied by 2 multiplied by 2 are the its factors. 3 into 3 is for 9, and for 10 it is 2 into 5. Okay, and now what we have to do is we have to find the common one from here. So 1 is okay, we can ignore. Then we have 2. I'm taking this 2, this 2, this 2, this 2 and this 2. For all this, 1 2 is common, right? Now coming to 3, this 3 I'm taking, this 3 and this 3, 3 is done. Next we have this 2. So for this 2, 1 2 is here, this one I'm taking, that's all. So 1 2. Next 5, 1's here, 1's here, 5's done. Then we are left with what? We are left with 1, 2 and 1, 3 only. So 2 multiplied by 3. So let's multiply them. But we will get 3 into 6 is 12. 3 into 6 into 2. 12 here. 12. And then 12 into 3 is 36. 36 into 10 is 360. So if you multiply all this, you will get 360 as the answer. Okay, we have already done these sort of question in our previous class. And now coming to answer number 10. What is said here is that find the smallest number that is multiple of all the numbers from 1 to 10. So that means we have to include 7 also. So include 7 also. So kids, we have LCM with 360. Okay, and now what we have to do, we have to include 7 also, which is nothing but LCM of both of these. Okay, so if we include 7 also here, what we will do, it will be 360 multiply with 7 because we don't have 7 anywhere common here. That means we will have to multiply this. So 360 into 7 is, this is 0, this is 42, and then 21, and 4 is 25. So this is our answer, 2520. Okay, so I hope this is clear what we have done. For all the numbers except 7, from 1 to 10, we have the LCM as 360. And in the next question, what we have to do, we have to include 7 also. So if I'm going to, I'm just marking here in red, if I'm going to include 7 here also, 7 is not common with anyone. That means in the end, I will have to multiply it by 7. That means I can multiply this by 7 to get, to get this number. Okay, so our this figure out is done. This is completed, and with the next topic of this chapter, that is co-prime numbers. Okay, not co-prime numbers, we have in the next topic we have prime numbers first. So we will pick the prime numbers in our next class, and I will see you all in the next class now.